Okay, guys, so this is our first problem. This is a free response problem, and this is a 3D moment problem. Okay, and this problem consists of three different parts. Part A asks, determine the resultant moment produced by the force at point A. Okay, so but before we doing this kind of problem, we need to lay out their coordinates. Like we need to lay out what their position vector is. So let's say we have 4 points right here. We have A, B, C, and D. So in the A is about the origin, so its coordinate will be out 0. Okay, and then B is right here, and B is 4 feet in the x direction, 3 feet in the y direction, and 2 feet in the negative z direction. Okay, and then for C, we see that C is 4 feet in the x direction, 3 feet in the y direction, positive y direction, and it doesn't have any position in the z direction, so 0. Okay, and then we have a D right here. For D is also 4 feet in the x direction, and it doesn't have any in the y and z direction. Okay, all right. And then for this kind of problem, next thing we have to do is that since part A is asked to find the resultant used by point A, so we know that for a 3D moment problem, for a force about a point, in this problem, point A, we have to use the cross product, which is the M equal to R cross F, okay? And then M will be MA because it's asking moment about point A. And then, but what about R and F, okay? So for F will always be the resultant force of F, unless it's asking you determine the resultant moment produced by the force, let's say F1 at point A. In that case, you have to use F1. But in this case, it only asks find the resultant moment produced by the force, which we assume that it will be the resultant force of these two. Okay. And then, but what about RAB? That's where the tricky part comes in. Okay. I want you guys to remember that if the question is asking you to find the force about point A, then R will be RAB. Why? Because you always want, so because for the cross product you always want to go from where the resultant moment will be applying to, which is A, to where the force is acting, which is at B. Okay, because the force is acting at B and you want to find out the moments at A. Okay, so you have to do RAD. Okay, but if the question says, if the question says find the force about point D, then you have to do RDB because that's from where you want the resultant moment to be to where the force is acting. Okay, and if the force is acting as C, then this will be RAC. Okay, I want to get that clear because this is the most common problem that I see when students working on this kind of problem and don't know how to find R's and don't know which R to use. Okay. Okay. And then next thing that we have to find out what RFR is. We know that FR is equal to F1 plus F2, right? Okay. And then you basically just adding them together. So FR will be 3 plus 4, 7i, plus 10 plus 12, 22j, and negative 5 plus negative 3, which will be negative 8k. Okay, and this is our FR. And then let me just write out my metrics. So MA will be equal to IJK. Okay. And we know that our RAB, so B minus A, since A is all about the origin, then RAB will simply just be B. So it'd be 4, 3, negative 2. It's 4, 3, negative 2. And this, you always want the first row to be the R and the second row to be the F, okay? 7, 22, negative 8, okay? And then just do the cross product. For my I, for my J, and for my K. Okay, so to find out what I is, simply cross out the row. Simply cross out the row where I, okay, and then cross out the column where I is at. Okay, and then do 3 multiplied by negative 8 minus negative 2 multiplied by 22. Okay. Okay, and then for the J, same thing. Cross out the row where J is, and cross out the column where J is, and do 4 multiplied by negative 8 minus negative 2 multiplied by 7. And don't forget that in front of the J, you always want a negative sign, okay? But you must have a positive sign in front of both I and K, but you always want to have a negative sign in front of J. Okay, and then do my K. So K, cross out the row where K is, and cross out the column where K is, and do 4 multiplied by 22 minus 3 multiplied by 7. Oh, my bad. Yeah, 4 multiplied by 22 and 3 multiplied by 7. Yeah, that's right. Okay, and then simply just calculate them. Okay, and I got my MA is equal to, when I do 3 multiplied by negative 8 minus negative 2 multiplied by 22, I get 20I. And then for this part, I have to do 4 multiplied by negative 8 minus negative 2 multiplied by 7. I got negative 18, but don't forget I have a negative sign in front of that. So negative 18 become a positive 18. Okay, and then for my K, I get 67K. Okay, and that's my answer. And that's my answer for part A. Okay. Let me scale this down. For part B, the question says, determine the magnitude and the coordinate direction angle. I'm repeating. Determine the magnitude and the coordinate direction angle for question A. Okay, so we want to find out the magnitude and the coordinate direction angle for part A. Okay, so the magnitude means that we need to find out what's the magnitude of this moment that we found right here, which we know the magnitude will simply equal to square root of 20 squared plus 18 squared plus 67 squared. And then you should get your magnitude of moment at A will be 72.2 pound per force. Okay, and this MA will also be MR. Okay, because problem A, I have to find out what moment A is, and then problem B is finding the magnitude of that moment A. Okay, so MA will be also be my MR. And then for the coordinate direction angle, you know that we have to apply alpha is equal to cosine inverse of f. It'll be m in this case because it's about the moment mx over mr. Beta is equal to cosine inverse of my over mr. Gamma is equal to cosine inverse of mz over mr. Guys, I'm writing all this out and I don't want to skip any steps because some of you might want to skip those kind of tedious steps to writing out the equation. But I want to write it out so everybody can understand that which formula that I'm applying. Okay, so alpha will be cosine inverse of mx, which will be 20, divided by mr, which would be 72.2, and I got 73.9 degree for alpha. And then for beta, cosine inverse of 18 divided by 72.2, and I get 75.56 degree for beta. And then for gamma, cosine inverse of 67 divided by 72.2, I got 21.88 degree for my gamma. Okay, and that's for part B. And then for part C is asking to determine the angle between F1 and F2. Okay, it says determine the angle between two forces. You know that we have to apply our dot product equation. And let me scale this down. I really want to do those kind of problems in person to you guys because that way I can explain it much better over the Zoom. But this class is about 350 students over 4 sessions. There's no LSU won't allow me to hold in person SI session if the class has over 100 students. And if I do a live Zoom session, then not a lot. I cannot find a perfect time for everybody to attend. So that's why I think recording would be the best option for everybody. So that way you guys can go back and review these videos at any time that you want it. Okay. And let's go back to the problem. Part C, okay, so we want to find out the theta between F1 and F2, which is this angle right here. Theta, we know that theta is equal to F1 vector multiplied by F2 vector divided by F1 magnitude multiplied by F2 magnitude. Okay, and then F1 will be 4 multiplied by 3 because you multiply by F1x by F2x, and then you're multiplying F2x multiplied by, F1x multiplied by F2x, and then you do F1z multiplied by F2z. Okay, and then let's find out what F1 is. So F1 will simply just be square root of 4 square plus 12 square minus 3 square. And I got 13 for that. And then F2, that's 3 square plus 10 square minus 5 square. And I get square root of 134 for that. Okay, so we know that it'll be 13 multiplied by square root of 134. Okay, and then do your calculation, you will get that theta will be equal to 12.35, 35, not 38, 35 degree. Okay, and that's for problem 1, and I'll see you in problem 2.